Welcome back to a short video on reviewing for vectors. And why don't we get started? Here is just a quick review of points versus vectors. So a point is a specific location in space, and a vector is directions, like how do you move from a point to another point. Kind of helpful to think of vectors as almost like slopes, like rises and runs, right? They're stair steps, only they're usually three-dimensional, so rise, run, and roll, perhaps. So if I wanted to plot the point 6, 1, 6, here's an XYZ axis here, and so I'm going to go 6 spaces in the positive x-axis, and so 1, 2, 3, 4, 5, 6 maybe. I'll go 1 step in the y-axis, and then I'll go 6 steps up. And so point A might be this location right here. And point B would be 4 steps in the x direction, and 8 steps in the y direction, and 1 step up. So that might be this location. And point C would be 9 steps over, 6 steps in the y direction, and 24 steps up. Whoa, look out. Yeah, maybe there. So there are our locations. And now if I wanted to describe how do I get from A to B, then I would need a vector. And so a vector is usually drawn with an arrow. So I can move this around a little bit. Oh, maybe not. Kind of odd how that worked there. But there, here is vector AB. And to describe vector AB, I could say that I move, some amount of space at this particular angle. But I usually talk about that in terms of x component, y component, and z component. And so to get from A to B, my x has to decrease by 2, my y has to increase by 7, and my z has to decrease by 5. And so you can write that in a couple different ways. You could write it with brackets. That would be a -2 and a +7 and a -5, I think it was. Yeah, -5. I'm not going to be able to, there. So that's pretty common to write it like that. Another very common thing to do is to, as I said, write it in component form. And if you do that, then you'll use I, J, and K to represent 1 step in the x direction, and J is 1 step in the y direction, and C is 1 step. K is 1 step in the z direction. And so you could write it like this: -2i plus 7j minus 5k. And it's actually a reason they use I and j and k. I is actually not unlike the imaginary number I. And there is a good reason to consider vectors like complex numbers, only instead of just real and imaginary, just 2 parts, there's actually 3 or maybe even 4 parts to this. And there's a whole field of study called quaternions that you may want to investigate this summer on your own if you want, that use I's and J's and K's, and it's kind of an extension of imaginary numbers and includes vectors and so on. So anyway, rambling. So there's AB. To get from there to there, I will go ahead and write AC as well. So AC, if I rotate it around a little bit, would be more like that, but my text isn't going to show up properly if I do that, so sorry. But to move from A to C, I'm increasing my x component by 3. I'm increasing my y component by 5. And I'm increasing my z component by 18. So there's AC. And why don't I also describe BC? So to go from B to C, that would be going backwards like this, and up. And so to go from B to C, my X has to increase by 2. My Y needs to decrease by 7. I'm not looking at the right stuff, am I? From B to C. All right, never mind. That's an increase of 5. To go from 8 to 6 is a backwards of 2. And 1 and 24 are 23 apart. So there's BC. So that's finding some vectors. Once we have vectors, we can do some helpful things with them. We can answer questions. Oh, here's one we answered already. What's the vector between points A, B, and AC? That doesn't make sense. What's the vector between points A and B? That would be vector AB. That would be this negative 20 or 2i plus 7j and minus 5k. So answered that question already. More interesting question is what's the distance between points B and C? So the distance between points B and C is also the same thing as the length of vector BC. And to find the length of a vector, it uses the Pythagorean theorem, kind of only in more than just 2 dimensions. So 5 squared plus 2 squared plus 23 squared, and take its square root. And I don't know that number off my head, so 5 squared plus 2 squared plus 23 squared is 558, and the square root of 558 is about 23.6. So the length here would be 23.6. Then one other type of question that we learned how to do to using vectors, and that was, where did it go? I don't know where my question was, but it was, what's the angle between things? I know I typed up that question earlier, but I'll type it up here then. So what is the angle between AB and AC? So AB is here, AC is here. It's hard to tell for sure because this isn't super perfectly to scale, but this angle, I wouldn't be surprised if that's somewhere around 90 degrees or something like that. How do I find that? And we learned that there is a formula for finding that. There's a type of multiplication called the dot product. And if you find the dot product, that's a number. If you compare that to the lengths of the vectors using this, you can calculate what theta is from all that. So why don't we do a couple calculations? In this case, U is vector AB, and V is vector AC. And so to make this work, I need a couple of things. I need the dot product, and I need the length of vector AB, and I need the length of vector AC. So let's see, what can we do first? Here's vector AB. Let's figure out what its length is. So vector AB is negative 2 plus 7j plus 5k. So if I do 2 squared, 7 squared, 5 squared, add them up and take its square root, that would be its length. So 2 squared plus 7 squared plus 5 squared is 78. Square root of 78 is the length of AB. So let me put that in here. Maybe. Square root of 78. And now let's find the length of AC. And so length of AC, same thing. 3 squared plus 5 squared plus 18 squared is 358. And I don't think that has a nice square root either, so I'll just write it as square root of 358. And now I need to find the dot product of these two. And so the dot product, how do we find a dot product again? That is the product sum of each of these terms. If we multiply the i's and the j's and the k's together and then add them all up, that is the dot product. So 3 times -2 is -6. Why? Why don't you let me type? -6. 5 times 7 is 35. 18 times -5, I think, is 90. Let's see here. Yep, -90. And if I then add those together, that would be the dot product. So -6 plus 35 minus 90 is -61. So putting all this together, we have an equation that we can solve. It's only got one variable in it, theta. And so that equation is -61 equals square root of 78 times square root of 358 times cosine of theta. And to solve this, I will divide both sides by the square roots here. That'll give me cosine of theta. And then I'll do an angle lookup. And so let me do some of that in the calculator here. -61. I'll divide by root 78, and I'll also divide by root 358. And that gives me -0.365. And so that is what theta, cosine of theta is equal to, -0.365. And then we do a angle lookup. So second cosine of well, I'll do answer here. And I got 111 roughly degrees. So angle here between those is about 111 degrees. And I think that kind of rings well with our picture here too, even as poorly drawn as it is. So there's an idea of points and vectors, and for your project, what I would suggest you do is maybe one of these questions. Give me a couple points. I use my phone number here, but give me a couple points and find the angle between a pair of those, which will involve, finding vectors and all that sort of stuff too. Hope that helps. We'll see you in the next video.